What's up everyone? Welcome back to Just Finished Coding. This is part 3 of our Night Tour series on Scratch 3. So let's get coding.
Just finished coding.
Now quick interjection here, if you've not watched parts 1 and 2, please watch them before you come here because we're picking up from where we left off and you'll be very lost. I'll leave a card for you right here. Please watch the videos and then come right back. If you're still here, I'm going to assume that you've watched parts 1 and 2, in which case let's get on with our night sprite. So within choose a sprite, click on upload a sprite, and this time I'm going to import all of the sprites including the night. So I'm just going to click open, and the last file, which is the numbers, should be as a sprite file. So in your costumes tab you should have 10 costumes with all the digits. Anyway, so now let's get into the night code. So I'm going to hide all of these sprites except for the night, and as you can see the night is already pretty humongous. So what I'm going to do is to reduce the size of the night, and I'm going to do that here itself, and I'm going to set it to be about 14. And now this is a lot more of a reasonable size, and now you can see when we hit the green flag and the board pops up, you can see that the knight fits almost perfectly on the square. And if you look at the costumes of the knight, you can see that it's pretty centralized, and you do not want this to happen. You want it to be right at the corner and right at the bottom of the the top left should be right at the bottom. So you're gonna have to move the costume like this and make sure that your knight is positioned this way. So now there won't be any change to the size, but this will help a lot when we are starting to move our knight and all of that. So do this as perfectly as you can, and I'll do that as well as I can and then be right back. So I just center the knight to the best of my abilities, and to do that I would actually recommend zooming in as much as you can. And anyway, so now that's done, I can get into the code. Just make sure that the square which is going to pop up in your vector mode will show towards that center position. Alright, so within our code, I'm going to start off the code not when the green flag is clicked, but when we receive start. Okay, so when we do that, I'm going to go to the extreme left of the screen, and I'm going to go about to the center position, but it's going to be a pretty random position actually. So the position is going to be -232, and the Y position I believe is 61. And this is just to show a message and say click on the starting square, so that the user knows that he's expected to click on the square where the knight first goes to. So what I'm going to do is within looks, grab this block which says save for 2 seconds, change that to be 1, and I'm going to change this hello message to be a click on the starting square. And once you're done with this, this will be your first script. And now you need to make a couple of functions. Okay, so head over to blocks, and the first function you need to make is going to be called find accessible squares. Okay, and this is responsible for, you guessed it, finding the accessible squares. And you want to add 2 inputs. The first input is going to be the X position. I'm going to call it position X, and the second input is going to be the Y position, which is position Y. Once you're done with that, you can optionally click run without screen refresh. I recommend not doing it because the program's fast as it is. So I'm just going to click OK. Alright, there we are. So now you should see this big block pop up, and I'm actually going to zoom out so that you guys can see better. So within this, what I'm first going to do in this block is to delete all of the accessible squares list. Because if there was something already in it, we sure as hell want to make sure that none of it is there, because pretty much all the squares that were accessible to the knight in the previous move is not going to be accessible in the next move. So delete all of accessible squares, and then you need a couple of add things to accessible squares. And here's what you need to do. Okay, so first you want to head over to operators and grab a whole bunch of joins. Okay, now why I'm doing this join is to make sure we get the whole thing in the format x comma y, but doing this is easier said than done. Okay, so what I'm going to do is to grab, I believe, 1, 2 and 3 joins, but within the second join I'm going to make a comma. Within the first join I'm going to grab a plus from operators. Actually grab 2 pluses and put them in both of them. Okay, And the reason I'm doing this is so that we have both position x and position y adding numbers regardless of whether they're positive or negative. So even if we are subtracting, we'll do plus minus 2 instead of minus 2. That'll just make our life a bit easier. Alright, so within the first one, I'm going to say position x, and within the second one, I'm going to say position y. Okay, and I'm going to put that entire block right here. And now I'm going to show you the board. So let's just say that your knight was right here. Now there are 8 accessible squares that it can go to. 1, 2, 3, 4, 5, 6. I'm sorry, once 1, 2, 3, 4, 5, 6, 7, and 8. Those are the 8 squares that the knight can go to. Now I'm going to start with this particular square right here and go in a counterclockwise order. Okay, so it's going to be the x coordinate plus 2, and the y coordinate is going to be minus 1. And I'm going to do that way, and you can really visualize this in your mind if you can imagine the coordinates. If you can't, then just copy me along. I really don't mind. So this first one is going to be plus 2 minus 1, and I'm going to duplicate this so that it makes the whole life easy. So now I'm going to do plus 1, plus 2, plus 1, and now you can duplicate this entire add actually, and you can duplicate all of these 4, and then you'd get 8 pretty fast. And now we need to change each of these. So this is going to be plus 1, this is going to be minus 1. I'm going to change all of the x's first. Okay, so this is going to be negative 2, this is also going to be negative 2, and this is going to be first negative 1, and this is going to be positive 1. And for our y positions, here's what we need. So the third one is going to be plus 2, the fourth one is going to be minus 2, the fifth one is going to be, I believe, 1, the sixth one is going to be negative 1, the seventh one is going to be negative 1 as well, and the eighth one, which is this square right here, that's going to be negative 2. That is pretty much it. And I think I have just 3 2's and 4 1's, so yeah, I definitely did make some mistakes, so I'll correct it and then be right back. So yeah, the couple of mistakes were as follows. The last one is minus 2, but this one is going to be not minus 1 but minus 2 as well, and this one's going to be positive 2, not negative 2. So now if you think about it, plus 2 minus 1 is going to be this, x is going to be plus 2, y is going to be plus 1 for this. In this case, y is going to be plus 2 and x is going to be plus 1. In this case, x is going to be minus 1 and y is going to be plus 2. In this case, x is going to be minus 2 and y is going to be plus 1. In this case, y is going to be negative 1 and x is going to be minus 2 as well. Then in this case, x is going to be minus 1 and y is going to be minus 2. And finally, in this case, x is going to be plus 1, but the y position is going to be minus 2. And those should correspond to all of these pluses and minuses which you have based on this x and y position of the knight. Now make sure you do this correctly, because in case you do not, then you're going to get some really weird errors. So this is a very important step. So now I'm going to make another block, and this one is going to be much simpler. So this is going to be saying find find truly accessible squares, and this finds all the squares that are truly accessible. And the difference between the accessible squares and the truly accessible squares is that the truly accessible squares are squares which have not been occupied before or actually exist on the board. So for example, if the knight were right here, then all the accessible squares would have some of them would have negative values and such. And obviously we cannot have a square with a negative x and y coordinate, so those would obviously not be truly accessible. So this truly accessible squares filters out our accessible squares list and make sure that we only have the squares that we need to be working with. So what you can do before you get into coding the truly accessible squares function is to just add this block after the find accessible squares itself, and this will ensure we can automatically find the truly accessible squares. So within truly accessible squares, first head over to variables and grab this block which says delete all of truly accessible squares. Now once you're done with that, now you need a repeat number of times loop, okay? And you need a counter. So I'm going to initialize a counter which is going to be called C once again, and I'm going to set it for the sprite only. Now click OK, and here I'm going to set C to be 1. Now instead of like a repeat number of times, you could do repeat 8 because the length of our truly accessible squares list is always going to be 8. But I just prefer to do like a repeat length of truly accessible squares. So repeat length of accessible squares, not truly accessible squares. And what we need to do in this case is just have an if condition. And right after that, I'm going to increment C right away so that I don't forget to do that. And before you increment that, right here, you need to have an equal to. And here, this is where things get a little bit tricky, okay? So you need item C of accessible squares. So I'm going to head over to variables, grab this block which says item 1, and then put the C in there. So item C of accessible squares. But keep in mind, if we're checking stuff in the board list, which is where like stuff is V or O, well, in that case, we definitely want to have a proper, the board index, right? And the index in accessible squares does not correspond to the board index at all. So what I'm going to do right now is to find the index number in the board coordinates list based on the element itself, and then use that board coordinates index to find the index in the board list. So now what I'm going to do is to say item number of thing in board coordinates, and I'm going to put this entire item C of accessible squares inside that, and now this is going to return the item number of that particular item which is in board coordinates, because obviously all the items in accessible squares are going to be in board coordinates with the exception of the negative values, which will get filtered right away. So now all we have to do is to just say item 1 of, and I'm just going to change that to be board, and I'm going to put this whole item number of item C in accessible squares in board coordinates inside that. And on our left side, I'm just going to say V, because that means the square is vacant, and if it is vacant, it means we can go to that square. So if this is the case, then what I'm going to do is to add this whole thing, actually not this whole thing, you can just add item C of accessible squares to truly accessible squares, and that is pretty much it. So this will give you all your truly accessible squares, and now you need to make the next function, which is finding the x and y coordinates, or rather moving to the x and y coordinates based on like that x core and y core input. Before I get into the function, I'm going to clean up my code, and now I'm going to head over to blocks once again, and I'm making a new block which is going to be called go to x comma y, and I'm going to add in two inputs. Okay, first one's going to be x core and the second one's going to be y core. Okay, and like always, these coordinates are technically inverted, so for the x position we need to go to, actually I'll be doing that right now. Okay, so head over to motion, grab a go to x, go to y, and now I'm gonna need a couple of things inside this x. So first head over to operators, grab a plus and put that in, and right after that we need a multiplied by within that second plus, and within the first multiplied by we need a minus. Okay, that is pretty much going to be it. Now within this first minus, I'm going to put in y core, and here I'm going to put -1. Okay, because right at the beginning when y core is going, if y core is 1 for example, we just want to go to start x, and let me actually hide all of these variables. I don't think there's any need for them to be showing right now, and yeah, this just declutters up our screen so much, and yeah, this is so much better. So now if this was hypothetically our, let's just take the top, okay, if that was our, let's just say in our x-axis first. So in this case, what we need to, what our input would be into this function is x core is going to be 1 and y core is going to be 1 as well. So now for our x position, what we need to do is to go to not start x plus like the dimension of the square, but we need to go to just start x, and that's because we need to decrement by 1 every single time we are going to the position. You can kind of view it as that whole -1 in the arithmetic series formula, but I'm not getting into that. Okay, so basically just assume that To go to the first coordinate, we need to go to start x minus 1 and that the coordinate minus 1 and we just need to go to start x itself. So that is the general idea. I hope you understood what I meant. Alright, so here on this first plus, I'm going to have start x, and after this, for this multiplied by, I'm going to have square dim. So a couple of maybe it was in the last video, I'm not so sure, the x core y core thing didn't show up, and that was because we didn't have square dim initialized just as yet. So what I'm going to do is to head over to the initializer, and I think it's time we initialize square dim. So I'm going to set square dim to be 45.2. That's our square dimension, and that was as close as I could get. It's still not perfect, but that's pretty much as close as I could get. Alright, so now within our knight, let's head back, and this time square dim would contribute to how much we'd have to like move to our right in this case. Okay, so now we need the y coordinate. So I'm going to duplicate this entire thing, but instead of a plus, I'm going to need a minus for y. So I'm going to grab a minus, I'm going to change this to be start y, and this whole thing is going to be pretty much the same. Okay, so I'm going to have x core instead of y core in this case, and we're just going to have that times square dim. Pretty much it. Pretty cool. Now once we go to this particular coordinate, we need to increment our score. Okay, so what I'm going to do is to just say change score by 1, and if you remembered in the last video, we had this variable called score added, which is responsible for finding out if the score has been added or not, and based on that we have this number imprint thing that's going to work out. So what I'm going to do right here is to say set score added to be yes, and I think we set score added to be no right before we like sent in the input or something like that. I'm not so sure. Anyway, we'll get into that later. So now once you have that in place, I'm going to throw out all of this code anyway. So now what we need to do is to have that entire, all of these functions basically do that thing when the move knight message is received. So head over to events, grab a when I receive move knight, and at this point in time, keep in mind that our knight may not be right at the front. So what I'll do is to add in this additional line of code which says go to front layer, and after this I'm going to grab that whole function which we had, go to xy, and the coordinates are going to be x core y core. Okay, that is going to be it. So now when I go full screen, I'm actually going to show you just to see that this x core and y core work. Okay, so now when I click this, don't worry about the knight, that's obviously messed up. But when I click on this particular coordinate, for example, you can see it's 2, 2. When I click here, it's 2, 3, 2, 4, and then when I click here, it gets to 2, 5. So that's the thing. So that's how our x coordinates and y coordinates work. Okay. So now go to xy. So you have this in place. And did I make a mistake here? I don't think I did. Anyway, let's forget about that. Oh yeah, this was a mistake. So not start x, the first one needs to be start y, and the second one needs to be start x. Oopsie. This needs to be start x. Okay, and I think the knight's probably going to move properly right now. Yep, it moves pretty good. Alright, so now when we receive move knight, we not just have to go to the coordinates, but we need to do certain things after this. Okay, the first thing we need to do is to broadcast this message called imprint, and this is going to be responsible for this whole like number sprite to put in the square number on that particular square. So I'm going to broadcast imprint, and after I'm done with that, I'm not going to wait for the code or anything. I'm going to have a condition checker. Okay, so first what I'm going to do is to say if score is not 0. Now the reason I'm saying if score is not 0 is to make sure that this is not the first move. So if it is the first move, I'm not going to mark that first square to be occupied, because the first square is not supposed to be occupied in the knight tour problem. So what I'm going to do is to say if score is not equal to 0, and obviously I need to put in a not right there. So head over to operators, grab a not, and put that in there. If this is not the case, then all I'm going to do is to replace. So head over to variables, grab a replace item, not 1, but item number of, and you want to change this accessible squares to be board first, and you can change this to be a thing to be an O. So we're basically marking the square as occupied. So replace item number of thing in board coordinates. So the similar trick, okay, of, and I'm going to say join x core comma y core, because that's really going to be our move. So head over to operators, grab a join, another join, and right here I'm going to put x core comma y core. Perfect. There we are. And I'm going to put that within that thing and put this entire thing right there. And that is going to be pretty much it. Okay, after this we need to use those two functions which we composed first. So first I'm going to say find the accessible squares, x core comma y core, and after we're done with that, what I'm going to do is to find out the truly accessible squares, because to find out our truly accessible squares we need to find the accessible squares first. So there we are. That is pretty much all we're going to be doing when we receive the move knight message, and that's it we'll be coding in this video. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.